Okay, welcome in. Today we're going to be discussing Module 2 for Week 2, so we'll just dive into it. Week 2 discusses place values, fractions, decimals, and percentages. So this is a review of basic math skills. Math is a cumulative process. Everything that you do in math builds upon the next thing. So it's important to get your foundations strong, and you're going to continue building on those. And if you have weaknesses at this level, you'll need to address those now. So we're going to take a look at these things and hopefully build you up for success in the future more difficult material that we'll cover. Your calculator, you should always check your answers. Use a calculator for the difficult multiplications or calculations, but you shouldn't rely on it. You should be able to maybe do the work and then check your work with a calculator. But when it's important that you get it right, it's never a bad thing to make use of a calculator to do the problem or to definitely check your answers. So
math is definitely a cumulative process. You didn't start out doing high school or college math.
I had no idea somebody else was about to say something there. Sorry. So addition, we'll talk about addition. Addition is just combining two or more numbers, right? So in this example here, we have 35 plus 43 equals 78. And if we add those things together, right? If I have 7 apples and I have 3 apples over there and I combine them, 7 plus 3 is 10, right? We won't go terribly deep into addition other than to say, let me get a marker here. I can't get a marker. That's not helpful. I can do this. We'll use small numbers because I don't want to draw something huge. But I had 7 plus 3, right? That is to say, on a number line, 1, 2, 3, 4, 5, 6, 7 is where I started. And then I added 3. So I moved over 1, 2, 3. And it's essentially just counting at that point, right? 7 plus 3 more ends us at 10, right? If you have double digits, carry the ones, right? If I have something like, say, this 35 plus, that's a bad one. Let's say 38 plus 27, right? We can put them in a column, add them together. 8 plus 7 is 15. I'll carry the 1 over into the tens column and then add those tens together. 1 plus 3 is 4, plus 2 more is 6. I apologize. They're tearing up a sidewalk outside. I hope you can't hear that, but I can. So anyway, I apologize. Okay. If we have units, kilograms, milligrams, pounds, centimeters, whatever, you need those units to be the same in order to add, right? I can take 6 units and add them to 33 units. I can take milligrams, add them to milligrams, kilograms, and add them to kilograms. These have meaning, right? Centimeters plus centimeters. If I have 3 feet and I add 2 more feet, I end up with 5 feet. And that makes sense, right? But I have, say, 3 feet and I add 7 kilograms to that. That doesn't mean anything, right? So this is meaningless to try to add those two. I can't add those two things that are not the same unit together. So I need to make sure that they're the same unit. And if they're different units, sometimes we can convert those. If I have, say, 2 feet and I add 24 inches, well, I know that 24 inches is 2 feet. So that's 2 feet plus another 2 feet, and that's 4 feet. We need to be careful with our units, make sure that they agree with each other before we try to add them together. And in these examples, and you can pause this video if you need to. I won't hang on this for very long, but they've added those numbers together here. Subtraction, very similar. If we're going to look at subtraction on a number line, this, I'll take this 5 minus 2. That's to say I started at 5 on the number line, and minus 2, I'm subtracting 2, so I'm just going to move to the left on that number line. So I should end up at 3, right? And I do. 5 minus 2 is 3. Once again, with subtraction, if I'm going to subtract things with units, I need to make sure that those units agree, right? So I take, say, 3 feet. I have a board that's 3 feet long, and I cut off 1 foot. Then I end up with a board that is 2 feet long. The units agree, so I can make this subtraction. If I have something that, say, that 3-foot board, and I cut off 1 kilogram, that I don't know what that means, right? I can't do that subtraction in different units. They need to be the same units for the subtraction to occur. So again, here we have a few examples, right? 1,000 milligrams minus 125 milligrams. They're the same unit. I can make that subtraction. Milliliters, same units, milligrams, and milliliters again. And again, these answers are here. You can pause that if you like, but we won't hang on it too much. And multiplication is next. There's a thing on my screen and I can't read it, but it's not on your screen. That's weird. I don't know how to get rid of it. There we go. Multiplication is adding a number to itself some number of times. So 3 times 4, for example. Oh my gosh, knock it off, lady. Where's my marker? So if I have 3 times 4, for example, 3 times 4 is taking 3 and adding it to itself 4 times. Or it's adding 4 to itself 3 times. And either way, we're going to get 12 out of that. Oh, they have that written right there. I could have cheated, right? So in this example, Jennifer took 500 milligrams of ibuprofen 3 times a day for 7 days. How many milligrams did she take per day? And how many milligrams did she take in 7 days? Well, if she's taking 500 milligrams 3 times per day for 7 days, that means in 1 day, she's taking 500 times 3. Let me get rid of all of these. She's taking 500 times 3, which is 500 plus 500 plus 500, which is 1,500 milligrams per day. But then she does that for 7 days. So that's that 1,500 added to itself 7 more times. So 1,500, 1,500. That's 1, 2, 3, 4, 5, 6, 7, right? This is very much the long way. In order to do this the quicker way, you just simply need to remember your multiplication tables of 0 through 9 or 1 through 10, however you do it. And then you can multiply the long way, or the short way, sorry. So that short way, I would take 1,500, multiply it by 7, and I just multiply this 7 through. 7 times 0 is 0. 7 times the next 0 is 0. 7 times the 5 is 35. So I'll write the 5 and carry my 3 that gets added to the next result. So 7 times 1 is 7, plus 10 more, sorry, plus 3 more is 10. We get 10,500. All right, take a moment here, pause the video and try these. And then in about 3 seconds, I will show the answers. And if you didn't get those, try again. But again, check your work with your calculator, write it out, do it by hand. Is, in my opinion, the best thing that you can do is to practice this. But yeah, always check these with the calculator if you want to double check and make sure. Yeah, make sure that you are getting the right answers for these multiplications. So for division, division is repeated subtraction, right? Multiplication, we said, was repeated addition. It's adding this number to itself, the same number over and over and over. And so division is a repeated subtraction. So when I say 350 divided by 7, that's saying how many times can I take 7 from 350? So I would take 350 and subtract 7 from it one time. That gives me 343. And then I would subtract 7 from it a second time. And I won't do it because I would have to do this 50 times, right? But that's essentially what I'm asking, is how many times can you remove 7 from 350 before you get to 0, right? That is, of course, the long way, right? The shorter way is the long division. If I take 7, divide it, 350. I know 7 can be taken from 3, but I can take 7 from 35 5 times. And 5 times 7 is 35. So doing so takes away all the 35. And I'm left with 0. And I can take 7 from 0 0 times. And I'm going to fill in zeros if I need to get to the decimal. And so it goes 50 times. But again, use a calculator, check these. But in my opinion, my personal opinion is that you should always try to do these by hand or get to the point where you can do them in your head and not rely on that calculator, but definitely use your calculator to check your work, especially if you're in an exam or you need your answer to be right for some important reason. Right? And here's a couple. Pause this here, give these guys a shot, and here are the answers. The next thing we would talk about is place values. And with place values, I mentioned this very briefly in the last video, but to the right of the decimal point are values smaller than 1. They go into the tenths, hundredths, and then the thousands, 10,000ths, and then the 100,000ths. And they continue on. After the 100,000ths, you would get the millionths and the 10 millionths and the 100 millionths, and then they would just continue on that way. To the left, we have periods, right? This is the ones period with ones, tens, and hundreds. The next is the thousandths period with the 1,000ths or just the thousandths, the 10,000ths, the 100,000ths, then the millions, 10 millionths, 100 millionths, then the billions, 10 billions, 100 billions, and they just continue onward, right? So it's also important to know these values. In America, we use commas to separate these periods and a decimal at the end of our ones. If you're from another country, particularly Latin countries, that might be opposite for you. So in America, get used to this notation, just as if you are from somewhere else, you would have had to have gotten used to the way that Americans write the date. We're wonky, we're the weird ones, we understand that, but when you're here, that's how it's done. All righty. So you can take a moment here. I mean, this one's not the hardest question you'll ever have in your life. It's asking, say, where's the tens? Well, what digit is in the tens? That would be a 2, right? The 10,000ths, you just have to find that number. That would be a 4, right? So I'll let you finish this chart. And then here are the answers to it. And if we want to write numbers out longhand, which you don't see very often, especially when these numbers get large, but if you're on the telephone with somebody, you'll typically say them this way, right? So this number here, it's very nice to see just a whole bunch of numbers written down, but if I call you up and you can't see what I'm writing, right? Because math is a very visual language. I have to convey this number to you in English. So this number is 4,385 and 93 hundredths. So I'm going to go bit by bit with each period, right? I'm going to start in the period. This is a thousands period. I'm going to say whatever number's in that thousands period, and then follow that up with 1,000. And then I'll move on. And I am going to try to avoid saying and anywhere until I get to the decimal point, right? Most of us will just habitually say and in the way that we say our numbers, and we understand what we're talking about. But the word and mathematically means to add something together, and it introduces ambiguity when you say the word and. So for this number down here, give it a shot. What do you think this number is? But again, I'm going to start with the period, right? The very leftmost period is the thousands period, and there's an 8 there. So that is 8,000. And then next I have 973. So I'll just write, oops, not a 9. 973. And, right, it's okay to use and because at that point I'm saying plus a little bit more, plus 7. And that 7 is in the 10th place. So I'm going to write 7/10. If I have another number, let's say a large number, let's say I have that one, right? I chose probably the largest thing in the world, and I might not have room to write it, but I'm going to start with that very leftmost period. This is the, well, this is the ones, this is the thousands, this is the millions period. So I'm going to write this as 235 million. There's no and, I just go into the next period. I'm in the thousands period, so I'm going to write the next number, 768, and follow that up with the period that it's in, the thousands. So 768 thousand. And then the ones, and that is just 902. But we don't write or say the ones period. We just assume if you just said 902, we know we're in the ones period. So just 902. And 143. And this is in the tens, the hundreds, and the thousands period, or sorry, place. So that's in the 143 ends in the thousands place. So I would say, and I wrote 143, I didn't write 143. This would be, and 143 thousandths. So yeah, it's a long one, but that's how we say those out. There is a rule. I should have hyphenated my 43. I can't remember. It's an English rule more than a math rule of when you hyphenate these words. The rule is numbers from 21 to 99. get hyphenated. But again, that's an English thing, not a math thing. I don't care, but your English teacher might. All right, rounding. We talked about rounding in the last video a little bit. So again, it's essentially, if I want to round something to, let's say, the 10th place, let's just round to the nearest tens. So I have to say 458, right? And I want to round this number to the nearest tens or 10. I'm going to identify where the tens place is, and that's the 5. And I always look at the next digit. If the next digit is 5 or more, I round up. If the next digit is 0 through 4, I just drop it and I turn it into a 0. So since the next digit is an 8, this rounds up to 460. If I wanted to round 322 to the nearest 10, again, the tens place is at 2. I look at the next digit. It's not large enough to justify an increase, so I leave it as a 2, and I turn that last digit into my 0. There's a few examples here. 23.3745. If I want to round this to the hundredths place, I need to identify where that is. The hundredths place is that 7. The next digit is not large enough to justify an increase, so I turn it into a 7. I leave it as a 7. And because these numbers that are being dropped are after the decimal, I just get rid of them. I don't have to write them as zeros anymore. I just dump them, right? If I am rounding this to the nearest thousandths in 25.3745, the thousandths place is here. The next digit is a 5 or larger, so I'm going to round that up, turn it into a 5, and then again drop that last digit. Okay. Now, if you have this last little bit right here, if you have a lot of kind of math that happens, you don't want to round every step of the way. In fact, you don't want to round more than once. And so you're going to save your rounding to the very end of whatever math that you're doing, right? Just round it in your final answer, and then you don't introduce, because rounding is an introduction of error. And if you keep rounding every step of the way, you get more and more error compounded into your calculations. So here's a few. Let me get rid of this here. You can pause the video and take a moment to practice these, but round these numbers to the 10th, the 100th, and then to the whole number. Right? And this bottom one here might be tricky for some people, but give it a shot. Pause it now. And here's the answers. Here's the real answers. There's a lady talking, and here's the answers. When we write numbers, we have some trailing zeros or leading zeros, right? So if I have a number, and this is I don't fully agree with the statement, because as a physicist, right here, this is saying this is incorrect. When we talk about things like significant figures, this is not necessarily incorrect. But if you have 0.125, if you don't know the number after the 5 is a 0, we shouldn't probably put the a bunch of zeros afterwards. So it's a very kind of narrow view of what we're looking at, but essentially what they're saying in this is that you shouldn't tack on these zeros, right? But if I have a number like, say, 0.125, I should always put that 0 there. And for me, the reason that is if I'm writing, and especially with, I'm a dude, I have terrible handwriting, and I thought about working on it, and then that was as far as I got. But if I'm writing on the board and my number is like 0.135, or if I'm writing on my paper and I can just barely see this teeny tiny little dot, I don't know if it's actually a decimal point or if it's, I don't know, some eraser mark or something that's fallen on the paper. So I should always put a 0.135, right? That way I know this 0 point, I know that's a decimal because I would never write 0.135 as a number, right? I would never have 0 leading a number to the left on a decimal point. And for all we care about, you shouldn't have zeros trailing after the number after the decimal point. So here are a few numbers. Pause this video. If it is correctly written, which I'll cheat for you, give you that one, that is correctly written. If it's correctly written, write a C. If otherwise you need to fix it, fix it. So go ahead and pause that video, try these now. And here are the answers. All right. When we talk about fractions, a fraction is the division essentially of two numbers. So like 1, 2. If we look at this as, say, a pizza, it's how many times I've cut the pizza or how many pieces I've cut the pizza into is the denominator. Let's say how many pieces there are. And the top is if I ate one, right? How many I took. Or how many I have, whatever you want to look at this, right? It's how many I have out of how many pieces that there are. Okay? So in this case, 3/4 of a cup, right? You're going to take a cup. That's my measuring cup here. If I fill this all the way up to the top, then I would cut this thing into 4 bits, and I would take and use 3 of those. And that's what essentially a fraction is. We can turn a fraction into a decimal. This 3/4. I can write as 3 divided by 4 or 3 divided by 4 this way, or I can do it in long division, 4 divided by 3. But if I actually do this calculation, I can turn it into a decimal. That ends up being 0.75. We can have whole numbers as well as fractions. This would be a mixed number. So 4½ means 4 plus 1/2. But again, like they say right here, this is bad notation. This is all bad notation. But this means 4 plus, but 1/2 is 0.5. And so we could write this as 4.5. Right. We'll try a few of these. Let's do one together. Let's do, let's say 5/16. And again, you can use your calculator if you like, but again, don't end up relying on your calculator for everything. So if I want to do 5/16 and I want to do this by hand, I can do long division, 16 into 5, right? That denominator comes out first. The numerator goes under the division symbol. I can't take 16 from 5, so I'm going to just tack on the next decimal in, which is the 10th place. 16 into 50, which I can do. I can take 16 from, oops, my thing is going wonky here. I can take 16 from 50 3 times, because 3 times 16 is 48. The difference here is 2. And as long as that difference is not 0, I'm going to keep going. I'll tack on the next 0, drop it down. I can take 16 from 20 one time. That's 16. I should have given myself more room, but that's 4. I'll tack on the next 0, and that's as far as I need to go. No, it's not, because I can take 2 16s, which is 32. So I'll minus 32 from that. Forgive my writing. I'm going to have to start going sideways here. Now, the difference here is 8. So I'm going to, again, tack on a 0 and drop it down, but I can take 16 from 80 5 times. So minus 80 gives me a 0, and so I'm done, right? I'll put my 0 in my ones column. My decimal goes directly above it. So here I get 0.3125. Pause the video here, try the rest of them. And here is the answers. Get my chicken scratch out of your way here. And then they've rounded everything to 1 decimal place, which I didn't see them ask to do that, but they just chose to anyway. Oh, they did ask that. So back this up, then round to the nearest 10th. So yeah. Okay. Good. All right. Percentages. Percentages represent a part of a whole number. So percent literally means out of 100. Per is divided by, and cent is 100, or out of 100. So 35% literally means 35 out of 100 or 35 over 100, right? A decimal can be turned into a percent by multiplying it by 100. So 0.25 multiplied by 100 gives you 25%. 7.37 multiplied by 100 turns it into 737%. So any of these, if I need to convert a decimal into a percentage, again, I just take we'll look at this one, 0.75, and I'll multiply it by 100, which just moves the decimal place over twice. 75%. Try the rest of these. And here are the answers. To go the other way, if I have a percentage and I want to convert it into a decimal, I just divide it by 100%, right? So 50% literally means 50 divided by 100, which is 0.5. And so I have a decimal of just 0.5. 590 divided by 100 turns it into 5.9. And so it's possible to have percentages that are larger than 1. It's possible to have a decimal converted into a percentage that is larger than 100%. So here's a few. 67%, let's take a look at this one. I'm just going to divide that by 100. That is 0.67 as a decimal. Pause this video now, try a few of these or all of them. And here are those answers. And that is it. Thanks for watching. Thanks for being here. And again, if you have any questions, feel free to contact me. The best way to contact me is through the inbox in Canvas. And have a good day.